Peanut butter?
Yeah, it works. Like,
I just
No, it
did
doesn't.
it.
I don't know.
Work in your hair.
oh,
You know what works best when you get gum in your hair? Scissors. Okay. Free haircut. All right. So, of course, we need to put down our 3 force diagrams. So we have this and this. We have this and this and this and this. This and this. As a side note, you remember yesterday when we were saying, Jack said, why don't you just take this weight minus that weight and then divide it by all of the masses and you could get the acceleration. Is there a way to do that in one statement now? What do you just have to include?
Minus.
Yeah, so there's just going to be a friction term involved in there, right? So it's going to be this weight minus the force of friction here. Does that make sense to everybody? Right. Okay, so, but I want to do it out. So here we go. Let's see. I'm just going to call that mg. I'm going to call that 2mg. I'm going to call that 3mg. This will be, do they call it anything? Like, is this T1 or T2?
Don't call anything.
Okay, good. So this will be T1. This will be T2. That's T2. That's T1. And this is Fn. So then we can make our statements, obviously. So we can say T1. Are we supposed to find the acceleration? Yeah, okay. T1 minus mg equals ma. Then we get T2. Oh, just kidding. Forgot the friction there. There it is. T2 minus T1 minus F sub F equals 2 ma. Yeah, and then this one, of course, is 3 mg minus T2 equals 3 ma. Okay, take a look at those things. Do they make sense? Any questions on the 4 statements? Better yet, do you see any mistakes? Okay, so now we can just like solve and sub, right? T1 is ma plus mg. T2 is 3 ma. Oh, sorry, just kidding. Whoops. Let me go back. It should be 3m. Oops. Come back. Stop. 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 Okay, should be 3mg minus 3ma. Because we're going to put the T2 over there, move that over there, so that's good. And now we can sub everything in and expand this one out. So T2, we get 3mg minus 3ma. We're subtracting T1, so we got to go negative on everything. Negative ma, negative mg. We get F sub f. Let's remember F sub f is mu F sub n. And for this middle, F sub n is 2mg. So that equals mu times 2mg. So when we subtract that, we get negative mu 2mg, and then that equals 2 ma. Oh, well, okay. Do you see, well, this is from I think it's from your formula sheet, right? F sub f is mu F sub n. And then when we look at our force diagram, do you see F sub n is equal to 2mg? So if F sub n is 2mg, do you see I can sub that in for F sub n? So I get mu 2mg. Okay, but good. I like how you're asking questions. That's good. And so now, of course, you can knock out all these m's. Okay, and then we just start moving all the a's to one side. So this is a 3a, or negative 3a, or negative a, it's negative 4a. So that comes over here, and we still get 6a on this side. On the other side, we have 3g minus g gives me 2g minus mu 2g. So I get 2g minus mu 2g. And so we get a is equal to something like g over 3 times 1 minus mu. Which part? Oh, right here? Oh, like when did I do this? Okay, did you see it in our force diagram here? Our force statement? See up here, we got T1 to the left, and, oh sorry, that was that one. And we have FF to the left. Why did I put M here? Oh, I mean, to go down, why did I put this into here? Or? Yeah, like this is just like taking F sub n and plugging in 2mg, because F sub n equals 2mg. So I'm just substituting from up here. Because this force statement, okay, I obviously screwed up by not, I cut a corner. And what I should have put is the sum of the forces in the y is equal to 0. And I should have put Fn minus 2mg is equal to 0. So I would get Fn equals 2mg. And that allows me to substitute it in here. And then now I can say F sub f is equal to mu 2mg. Then I can plug it in, and get my answer. Okay? And so this 10 divided by 3 is like 3.3, and then 0.7 divided by 3 is around 2 or something. Okay, any questions on that one? How did we get out of here? 46? Okay. Any questions on? Yeah, I know exactly. All right, so here we go.